Hello, and welcome. Today we will be talking about what is ESP32 Devkit, what is the difference between ESP37 and ESP8266, and how to collect DHT data and display it on a web server. The ESP32 Devkit is a development board for the ESP32 microcontroller, featuring microcontroller. The ESP32 is a dual-core microcontroller with integrated Wi-Fi and Bluetooth based on the Xtensa LX6 CPU architecture. Development features: it includes a USB to UART interface for programming and debugging, as well as GPIO pins for connecting external sensors and peripherals. Wireless capabilities: the ESP32 supports both Wi-Fi and Bluetooth, classic and low energy, making it suitable for various wireless applications. Power efficiency: the ESP32 is known for its low power consumption, making it ideal for battery-powered and energy-efficient IoT devices. Arduino compatibility: developers can use the Arduino IDE with ESP32 Devkit, simplifying development, especially for those familiar with Arduino. Development tools: multiple development tools like Arduino IDE, Platform I/O, and Espressif IDF are available for programming and application development. Community support: the ESP32 has a strong developer community, providing access to resources, tutorials, and libraries, making it easier to start and progress with projects. For this connection, connect the GND pin of the DHT to GND of the ESP2. Connect the VCC pin of the DHT to 3v3 of the ESP32. Connect the data pin of the DHT to D27 of the ESP32. This Arduino code sets up a web server using the ESP Async Web Server library to display temperature and humidity readings from a DHT11 sensor on a web page. Here's an explanation of the code. Library imports. Import necessary libraries, including Wi-Fi, the ESP Async Web Server, Adafruit_sensor, and the DHT library. Network credentials. Replace _with _ your _SSID with your Wi-Fi network's SSID. Replace _with your password with your Wi-Fi network's password. DHT sensor configuration. Define the digital pin, DIT pin, to which the DHT sensor is connected, example, DIT pin 27. Specify the type of DHT sensor being used, example, DHT-TYPE DHT11. Async Web Server initialization. Create a web server, Async Web Server, on port 80 to handle incoming web requests. Reading temperature and humidity. Create a function read DHT temperature to read the temperature from the DHT sensor. Read the temperature from the DHT sensor. Check if the reading is valid, not NaN. If valid, return the temperature as a string, otherwise, return and print an error message. Create a similar function read DHT humidity to read and return humidity data. Serial output. Print the temperature and humidity readings to the serial monitor for debugging purposes. The code essentially sets up a web server that provides real-time temperature and humidity readings from a DHT11 sensor when accessed via a web browser. Users can navigate to the server's IP address to view the data. Make sure to replace the Wi-Fi network credentials with your own, and ensure the sensor is correctly connected to the specified pin or modify the DIT pin value accordingly. This code is a HTML template for a web page that is designed to display temperature and humidity readings from an ESP32-based server. Here's an explanation of the key components. HTML structure. This is a standard HTML document with the following components. The declaration of the HTML document contains meta information and links to external resources like CSS and fonts. Contains the visible content of the web page. Viewport meta tag. This tag sets the viewport's initial scale to 1, which ensures that the web page is displayed at the correct size on different devices. External stylesheet. This line links to an external stylesheet, CSS, hosted on a content delivery network, CDN. The stylesheet is Font Awesome, a popular icon library. Internal styles. These are CSS styles defined within the tags in the HTML document. They are used to format the page elements. Some key styles. Font family sets the font for the page to Arial. Text align centers the content of the page. Font size sets the font size for various elements. Page content. A level 2 heading with the text ESP32 DHT server, typically displayed as a large header. 2 elements, These paragraphs display temperature and humidity information. Inside each element, an icon element from Font Awesome, representing a thermometer or water droplet, styled with specific colors. A span element with a class for styling labels. Or, these spans will be dynamically updated with temperature and humidity values. The initial placeholders are %temperature % and %humidity %, which will be replaced with actual values via JavaScript. Degree C or %, these elements represent units, degrees Celsius or %, and are styled with the units class. JavaScript section. This script section contains JavaScript code to update the temperature and humidity values on the web page without requiring a full page refresh. 2 set interval functions. These functions repeatedly send XML HTTP requests to the server to fetch temperature and humidity values. XHTTP. On read a state change, this function handles the response from the server and updates the corresponding HTML element's content when the response is received. XHTTP.open, get/temperature, true, or XHTTP.open, get/humidity, true. These lines specify the HTTP GET requests to fetch temperature and humidity data from the server endpoints /temperature and /humidity. XHTTP.send. This line sends the GET request to the server. The intervals are set to 10,000 milliseconds, 10 seconds, so the temperature and humidity values will be updated every 10 seconds. This HTML template creates a web page that displays temperature and humidity readings dynamically fetched from an ESP32 server using XML HTTP requests. The ESP32 server should provide temperature and humidity data when requested at the specified endpoints /temperature and /humidity. This Arduino code extends the previous example by incorporating a web server using the ESP Async Web Server library to display real-time temperature and humidity data from a DHT11 sensor. Here's an explanation of the code. Processor function, string processor, const string and var. Sad face. This function is a custom processor for placeholders in the HTML template. After you have uploaded the code, you will need to open the serial monitor to get the address to access the web server. Thanks for watching.